Hello, how are you? Now today we are going to discuss one of the very important subtopic from the topic of differential equation, and this is exact differential equation. Now before we dive into this subtopic, let me remind you on something from differentiation. Yes, we know that if you have a function f of x comma y, this is a function of several variables, a function of two variables x and y. So if you have this function, we know that we can find the total differential of our function, and the total differential can be written this way: df of x comma y is written as, because we have more than one variable, then we are going to find the partial derivative. So it is partial f with respect to the first variable dx plus partial f with respect to the second variable dy, and this is what we call total differential, and the right hand side is 0 because we know from the original function the value of a constant, derivative of constant, we know it is 0. Now if now we decide to assign a partial f, partial x to be m, and partial f, partial n, y to be equal to n, then our equation of total differential can be written as m dx plus n dy equals to 0. Now this arrangement is very important. Once you are given a certain equation of first order and you are required to find the solution, then if you can write it in this form, you are along the correct path to know if the differential equation is exact or not. Now after arranging it in this form, you will have to check if your differential equation is exact. This is where the concept of exact differential equation originates. Now where do we start from? We are going to see that from the first equation, f of x comma y equals to constant. Now the concept of differentiation says if the given function, function f of x comma y is continuous, then the corresponding second partial derivatives, so if I find the second partial derivative df dy dx will be equal to df dx dy. This is very important, and remember that if you say df dx, this we say it is m, dx df dy. So df dx is m, so this is m, and the df dy is n, so this is dn. Sorry, this is supposed to be y. So here we have y and here we have x. Now you see this condition, this is the concept of exact differential equation. So from the original total differential equation, this one, it will be exact. It will be exact if we have a partial m partial y equals to partial n partial x. So if you are given a differential equation, you have to arrange it in this format, this one. After arranging it, you have to find the partial derivative of m with respect to y. Please be very careful because the variables are changing. Here is m dx. So if m is a coefficient of dx, then you are going to find partial m partial y. And if n is a coefficient of y, then you are going to find partial n partial x. Don't interchange the variables. Now, and if you find those partial derivatives and you find that they are similar, then you conclude that your differential equation is exact. And then after knowing it is exact, now we are going to see how to solve. In my next video, we'll see how to solve these what we call exact differential equations. So Thank you so much for listening. I invite you to continue commenting, continue to like, to subscribe our channel, invite other friends. Thank you very much. My name is Teacher Augustine Kamima.